Hello, welcome to the FCOE demo from Blade Network Technologies. I am Rakesh Saha, and today I'll be showing you industry's first 10 gig FCOE CE transit switch. For the demo today, this is the setup we have, where we have within one chassis one IBM Blade server connected to a QLogic CNA, which is converged network adapter, which can support FCOE and Ethernet traffic at the same time, which is then connected to Blade 10 gig FCOE CEE transit switch, which is then connected to an FCF gateway, which understands FCOE and FC, and that is connected to an IBM DS4K 4 gig array. First, we will take a look at how the data transfer happens in an FCOE setup. So we have the standard setup that we just saw. In the beginning, what would happen is that the CNA would use FCOE FIP protocol to actually discover the FCF gateway through the FCOE transit switch and then establish a virtual link. The job of the FCOE CE transit switch, which is the Blade 10 gig in the picture, is to provide ACL based security, which is the equivalent of FC security, and also to provide DCB standards such as PFC, ETS, and DCBX. The FCF itself provides the encapsulation and decapsulation of the FCOE traffic and the FC traffic, and it also provides fiber channel fabric services. The server OS itself, its FC stack is unmodified. It does the reads and write to the remote disk array as it does before in a traditional fiber channel network. Then the next setup that we have introduced two more blades into the setup to load more traffic onto the FCOE blade server to show the converged nature of the FCOE CE switch. In this setup, what we will see is that we will be running three different kinds of streams. First is the FCOE traffic itself going to the disk. Second is the video traffic actually getting streamed from IBM Blade Server 2 to IBM Blade Server 1, and then two instances of IO meter doing the regular Ethernet traffic to IBM Blade Server 1. And the idea here is that when the switch sees congestion in the network, it will use priority flow control protocol, the PFC protocol, to actually manage the congestion and make sure that no storage traffic is lost. So now we go ahead and start our demo. So let me bring up the appropriate screens. So the first thing I would like to show you is that the console of the FCOE CE 10 gig blade switch. Here what we have is essentially a screen which is showing us the fact that there is an FCOE connection which has been established through the JANICE, the IBM 10 gig switch. So we have here this particular ACL which shows that we will allow the traffic to happen through the 10 gig blade switch for the FCOE. And I will now go to the FCOE server blade as we had seen. So you can see here we actually have the video streaming right now, and this is running at the priority, the 802.1p priority 4. Then we have the IO meter traffic that I would stop here and then restart to show that we are starting it right now. So I'll go and start the traffic. So say save, and we can see that the IO meter is showing certain throughput happening in megabytes per second, and when this throughput is happening, we also have the video running in parallel. So this is showing two kinds of Ethernet traffic happening in parallel through the same switch, and then we will go ahead and introduce the storage traffic to see how the switch behaves. So I'll go ahead and start the DT tool, which is an open source tool for doing IO test. So I'll go ahead and hit enter over here, and what we will see is that while DT is doing its initial burst of traffic, there is congestion in the switch, and because of that the throughput for the Ethernet drops while the video is still going on okay, and the storage traffic is going on okay without any loss of data. And to see that there is actually no loss of data, we will actually go to the switch and look at the appropriate counters over there. So I will go ahead and recall some of the commands that I have provided before just for the sake of time. So this is port 11 is the port connected to the blade server itself, and if I hit enter on that, what we see here is that there are a lot of traffic going on. And then the thing to note here is the fact that there is a priority flow control packets, and you can see we are sending certain amount of priority flow control packets to this server, and this is because this is in response to the fact that we are receiving congestion from the FCF gateway. So if I were to go to the port which has the FCF gateway attached to it, which is port 18 in this demo, we can see here that we are receiving priority flow control packets from the FCF gateway. And what it means is that when DT tool started its data traffic, the 4 gig IBM DS4K disk drive was not able to absorb the burst at that time, so it put pressure on the FCF gateway. The FCF gateway then used PFC protocol to send a PFC pause packet to blade switch, and you can see the number of pause packets being sent by the FCF gateway is of the order of thousands, whereas the pause packet that is being sent by the blade switch to the host is of the order of 6,000 also, but the number itself is quite less, indicating that blade switch is able to absorb as much congestion as it can and then only send the congestion notification to its peer. So this shows that we are not losing any packets in spite of having congestion in the storage network. The discards that we are seeing here is for the Ethernet traffic, because Ethernet traffic does not have the PFC guarantee attached to it, and that is the expected behavior. So if I go back and take a look at all the screens, what we have here is the video streaming running. We have the storage traffic going on in parallel, and we have another type of Ethernet traffic going on in parallel. So you can see this is a converged blade switch which is doing Ethernet and FCOE traffic at the same time and is able to give a very good throughput on all the three types of traffic. And that corresponds to this particular screen that we had before. So I would like to end this demo with this particular summary. Let me move on to the next slide because we have seen this already, which is that the Blade 10 gig switch is standards-based open FCOE solution. It can work with any FCOE standard compliant gateway. We do lossless transfer of fiber channel traffic. The congestion management is based on the PFC standard. We support Ethernet and fiber channel traffic simultaneously. And the design is such that the preference is given to storage traffic, and we will pause or drop Ethernet traffic in case of congestion first before impacting storage traffic if at all. So that is the end of the demo. Thank you.